Now, I was just recently in Denver. I went to Denver for an American Astronomical Society meeting, and we love to talk about how the AAS meeting that happens in the winter is the Super Bowl of astronomy, that it's the biggest astronomy meeting in the United States. It has thousands and thousands of people coming, so I know what you're thinking. This one must be the World Cup of astronomy, right? Actually, no. It's a much smaller meeting. Maybe a quarter of the astronomers go to it. Not as many talks, not as many presentations, so it's really more like the Stanley Cup of astronomy. But that said, it was a great meeting. We got to put John Denver up there and Lucifer. I heard somebody call that Lucifer, so we got Lucifer up there. And it was pretty cool. You can see Tabby Star here is up there, but we have a special guest here joining us. Yao Yin from the Thacher School in Ojai is going to join us. We have a special guest, so come on up and have a seat here.
Hello.
Is your microphone on and working?
I think so.
Okay.
Is it?
Can we everybody hear her? Perfect.
Hi, everyone.
So now, you were part of a session called Stars That Make You Say WTF. Now, it's not what you think. It's where's the flux? And flux is the light that's coming from the star. And we've talked about Tabby stars, we're going to call it. We'll give it the nickname. It's that star that we were talking, could it be an alien megastructure in front of it that's blocking the light from it? So every once in a while it would have these massive dips where it would get dimmer, and then it would get brighter again, and then dimmer again by huge amounts. And it's weird, really, really, really strange. So a lot of astronomers were curious about it. They went and studied it. We had the press throwing out ideas that maybe it's aliens gathering that light for their power uses. Well, not so much. But you got involved in this. And of course, this was what people were thinking. Something's blocking out the light in the foreground. But where did you make observations, and how did you get involved?
So I'm from the Thacher School. We're a private boarding school in Ojai, California. It's a really small town, very hippie. But we had this observatory renovated in 2016, and we were really excited about it. So we went to this public talk that Dr. Boyajian, whom Tabby Star is named after, she gave a talk in Santa Barbara, and we got really inspired by the entire situation and the opportunities we see with our own telescope and all that. So we decided to take data on Tabby Star, I think in May of 2017. So we have a bunch of data on this really weird star, and we started investigating it.
So this is you and the team that were taking the observations?
Yes, I'm the one with bangs in the middle, and Dr. Boyajian is the one wearing the long skirt right next to me.
Exactly. So now you were taking data of this star, but you weren't just measuring the brightness by itself. You were putting filters in the way. You were measuring it in just certain colors, weren't you?
Yes, we were measuring it in 4 different bands. So photometric bands is basically like colors. So we measure it in V band, G band, which is green, R band, and I band, which is infrared. Red, R band is red. So, and we found this really interesting thing called chromatic dipping.
Okay, well, are these dips you measured right here?
No, these are actually from Dr. Boyajian's original paper, in which she discovered the really crazy dips, which got people thinking that it might be alien megastructures.
Okay, but this is some of the data you took.
Yes, this is original data light curve from the Thacher Observatory since, I think, May of 2017. Yep.
Okay, so very, very cool. And these are the different bands. So essentially, you've color-coded them here for us and plotted all the data together. But there's something very interesting going on, that they aren't dimming the same, are they?
Nope. So like I mentioned, we found this chromatic dimming effect, which means that light in different wavelengths are blocked differently by the whatever material that's obscuring Tabby Star. So why this is happening is actually the same reason why we see the sky as blue color, because different wavelengths of light is actually scattered or absorbed differently by the dust that is blocking Tabby Star. So if it is alien megastructures, the light from all different photometric bands will be blocked the same way by these huge structures. But we didn't found that. Instead, shorter wavelengths, for example, green light, are blocked more than longer wavelengths in like infrared or red. So we expect that this indicates that whatever's blocking Tabby Star is very, very small grains.
Okay, so very small grains, but you found something else interesting. That's their conclusions they presented. that the long-term dimming, the star is also dimming on long-term scales where very slowly it gets dimmer and then it'll brighten very, very over a long period of time, that might be caused by a different kind of dust.
Yeah, so we measure the RV values. RV value is basically measuring how big the dust grains are blocking Tabby Star. We measure the RV values of the short-term dimming, but another colleague of ours on Dr. Bowden's team and other astronomers measured the value of these long-term dimming effects. So the light curves you saw earlier in the crazy plots, we suspect that light curve might be caused by 2 or even more independent events happening at the same time. So it might not just be one kind of material blocking the star. It might be many different kinds of materials.
Different kinds of materials.
Yeah.
Well, awesome. Now, has this study of yours been published yet? Are you guys writing it up?
No, not yet. We are working on some paper collaborating with Dr. Bowden's
Okay,
team.
well, that's really great. But I did get to see them present it at this meeting I was at in front of the press. You did a press release on it.
Yeah.
Did any papers publish anything about your work? Did you make it in any newspapers?
I think so. I think like space.com, things like that. Not like the huge ones. But
Yeah, well, space.com is pretty big. Anybody in here go to space.com?
Yeah.
Yeah, see, so very cool. You've already made a bit of a splash. Anyway, thank you so much for joining us. It was awesome to have you here.
Thank
It's
you.
a super pleasure to have you. Perhaps the youngest guest we've ever had. A few questions, sure.
Yeah, so would this be an analog to the rings of Saturn around a star? I mean,
Yeah, there are still many hypotheses that could be possible, but we can't really tell right now. It might be planets colliding and things like that. And quoting my partner Alejandro Wilcox, who is not here right now, but he said in a press conference that it might be microscopic aliens. So,
Yeah, he had to throw that out there. Of course.
yeah.
Any other questions? Yeah, back
How
up
far
here.
away is the star?
I think it's about 1,070 light years away. About that. Don't quote me though. In that magnitude.
Up front here.
Yeah, I don't know how any of this works, but would there be any difficulty measuring or differentiating between small grains very close to the star versus large grains far away from the star? Or are your ranges, large enough that that's sort of not mattering much?
I don't think we can actually distinct how far away the material is from the star, but yeah, it could be just interstellar medium along the line of sight to the star.
Yeah, in fact, dust grains close to the star should be warmed by the star and would glow in the infrared. I don't know to what limit we've measured how much dust could be there yet based upon that glow, but dust grains that are far away and cold, let's say it's 2 rogue planets that aren't around any stars that collided, very unlikely, but maybe, that stuff would be cold and it wouldn't glow, so it's part of the mystery of this star.
I have just one question. I remember when Tabby Star, as it was announced long ago, was first announced, that one of the mysteries of it was that plates taken of it, like in the 19th or early 20th century, showed the star much brighter than now on average. Has there been any insight into that you know of?
Yeah, we looked into a lot of papers. So one of them actually measured the really long-term dimming effect for like about 100 years of Tabby Star. And it found that it has been dimming all this way long for like 1 to 2%. So it could be many different scenarios happening at the same time.
So I do the same question I sort of discussed with you, Dr. Reitzel. Why don't we see this phenomenon way more often? Why
Well,
is it just-
hold on to that question.
Okay.
So exactly. Anyway, once again, let's thank our guests. And I'll answer both questions in a moment. What Bill just asked is, why don't we see this more often? Have we seen it? The answer is yes. Epsilon Aurigae is a star that has unusual, weird dimming. And it seems to happen on periods, I think it's every 29 years or something like that. But we didn't know how far away it was. These stars do exist. They are common, but they're rare enough that without surveys out there looking for them and staring at the whole sky, we don't find them very often. But this is one that's been out there a long time. It's been dimming a long time.
Yeah, this one's actually bright enough to see by eye.
Yeah, and you can actually see it. And where, is it Northern Hemisphere?
Yeah, it's in the constellation Auriga near the bright star Capella, and there's a kind of a long triangle. It's one of those 3 stars, which are called the kids. It's supposed to be Auriga holding some little goats. So it's
Very
that
cool.
little patch of kids.
Awesome.